Okay, so B would look like this. Hopefully you can do B and C by yourself without too much more trouble. Notice how I'm removing all labels. That includes dollar signs, by the way, and things like that. 109, 111, 67, and 15. Quick question. Mr. Tong? Why did so many event matrices? Why did the first mathematician say, I'm going to do this way? Could it be he just didn't want to write down all the dollar signs and the labels for the axis for the table? The answer is yes. He just didn't want to bother. He's going to do a lot of math with this thing, and the last thing he wants to do is write down the table every stinking time. So a matrix is really just a table. That's all it is. It's a table of values. Or a table of processes. But once we started playing with these things, we discovered some interesting things. Here's what I'm going to ask you to do. I'm going to ask you to do A plus B, and I'm not going to tell you how. Yes, I'm that kind of person. I'm not going to tell you how. Do A plus B and tell me what you get. I'll wait 30 seconds before I start doing it myself. You'll be like, oh, I get it. Even if you don't. Ms. Young, you with me? You know how to do it? Think you do? Oh, I did it. 221 plus 215. Up here, this would be 436.
Yeah.
Right? I'm just adding them up, right? 239. There's a 50-50 chance this is what they wanted you to do on the ACT test. I'm not sure. I haven't read I don't know what the problem is. I think it's possible multiplication.
Did we do the cross thing? Or is this it?
No, we're not doing any crossing. We're just adding the numbers. Which brings up a question which I need to talk about, and I probably should have addressed it. I was going to address it in a moment, but then I forgot to do something else instead. So give me a second on this. You good?
Mm-hmm.
Here we add matrices now. Now, before I move on, there's two questions I need to address. One of them is, what does A plus B mean? What does it mean?
The values.
Added together, which in this case would be what?
The average? No.
It wouldn't be the average.
No, it would not be the average.
What would it be? It would be the total for what?
Dollars sold and numbers sold.
For whatever these are. This is two different restaurants or whatever.
Yeah.
So it would be the total between the two restaurants. Agreed? So it's whatever. It's adding up the responses from both things. If somebody said, hey, aren't I supposed to do a crossing thing? It's my bad. I should have mentioned this. When we were doing matrices, I called them matrices, but we had straight lines. What's the difference? This means to take the determinant of a matrix. Okay? So that's a mathematical function like adding them or subtracting or multiplying is to take the determinant. We will be doing that again later on. So straight lines mean do what we did where you add the two rows, you do the crossing thing. Right now we're just doing addition. Is that okay? Okay, everybody blow through and do the next one. Should be able to do B plus C, no problem. I said there's a lot of worksheets in this chapter. This is why. A bunch here that are just not got anything to them. Okay, so I'm going to double the prices. So what would that mean I should do? Mr. Miranda. A, right? If I'm going to double the prices, what would that matrix look like? And multiply everything inside by 2. So we would write that process as 2A, and then we do what? 32, 20, 128, 64, 10, 5, 132, 150. That make sense? Got it? Can we do this? I think matrices are easy. Good thing. At least until we get to matrix multiplication, and then, yeah. No, you're not an expert in matrix multiplication because it hasn't been taught to you before, but I would like to point out that you already know how to do this because you do.
Is it each like piece is equal to
If they're equal, if the matrix is equal, each place has to be equal to each other, right?
Got it.
So what would I do? I would look at this and go, oh my, I got lots of algebra to do. Isn't this fun?
Oh.
So if 3x must be equal to 27, so 3x must be equal to 27, so x must be equal to 9, and so that's one of them. 4y's must be equal to 16, or negative 16, so therefore y must be equal to negative 4. Negative 3w's must be equal to negative 48, therefore w is equal to 16. And 7z is equal to 49, so therefore z must be equal to 7. Boom, 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 boom. First one's done.
Okay, I get it.
You know there's no matrix form for this because I'm solving for the variables. Okay. Yeah?
Yeah, it's
like Massachusetts area. All right, here we go. I've got a matrix. It is 0, 8, negative 6. Another one, 4, 3, 10. Dot multiplication with 5, negative 2, 6, 9, 1, 0, 3, 4, negative 3. With me so far? Now we're going to do something really bizarre, so be ready. Here it comes.
Wait, where is this?
I'm on the front of 6, 8.
No. What the heck?
Get there.
What?
Front of 6, 8.
I don't like this.
I'm multiplying these two things together. I haven't done anything yet except write down the problem. But I'm about to do something awful. What I'm about to do that's awful, I need to multiply these together. So we're going to do what's called row column. Row column. How do I do that? I'm going to look at this row. I'm going to look at this column. First thing you need to know is this. If they're not the same number of numbers, it can't be done. There is no solution. But there's 3 here and 3 here, so I can do the work. So here's what I do. I go 0 times 5, which is 0 plus 8 times 9. That would be 8 times 9 plus negative 6 times 3. Put that all in my calculator. I get 72 minus 18. That would be 54. Is that right? So up here in this corner, I'm going to write a 54. Row times column gives me that one there. Oh, yeah. Oh, yeah. Now I want to do the second one, right? So I'm going to go row times column. Oh, yeah. Oh, yeah. So 0 times negative 2 is 0 plus 8 plus negative 24 gives me negative 16. Row column. 0, 0, 18. That's what goes there. I've done the first row. Now what do I do? The second row. This times this. 4 times 5 plus 3 times 9 plus 3 times 10 equals 30, 57, 77. row column. Did I do that right? I did it right, didn't I? Did I lose my train of thought? No, I didn't. I got it good. Row column. So this is going to be 4 times -2 plus 3 times 1 plus 10 times 4. And that gives me -8, -5, 35. And they did the first one for you, which is -6. And congratulations, I'm done.
Okay, that's not too
It's just awful. It's okay, but it's just awful.
bad.
Now, the first question that should leap to your mind is, when am I ever going to use this? We're in pre-calculus. I might be able to answer that question. We take a look at the problem below. It says, when do I ever use this? I see it. So I'm going to go ahead and build myself a table. With me? I was up here briefly because I'm only showing you how to multiply these together once where there's a use to it. Here we go. I need 4 kilograms of onions, 6 kilograms of potatoes. Sorry, I used kilograms. She said pounds. I'm sorry. I'm just weird. 2 kilograms of tomatoes. My friend, Mr. X, wants to buy 3 kilograms of onions, 2 kilograms of potatoes, 1 kilogram of tomatoes. So I made a table, didn't I? See the table down there? It's 4, 6, 2, 3, 2, 1. See that? Can we see that? Are you with me? Okay, then I said the cost of onions are 5 rupees. The cost of potatoes are 10 rupees. And the cost of tomatoes are 8 rupees per kilogram. Now multiply them together. That's Indian money. One of the most populous countries on the planet. You should know what their money looks like. So I'm going to go ahead and multiply these together. So I got 4, 6, 2, 3, 2, 1. Over here times, and I'm going to go 5, 10, 8. Are we ready? So I'm going to go row, column. So this is going to be 20 plus 60 plus 16. 96? Row, column. 15 plus 20 plus 8. 43? Should have got 48 maybe. No, I didn't. Okay, good. Oh, good. What does that mean? What's the last column mean? I used matrix math. What does it mean? What did I do to get this number? I took the 4 onions I wanted to buy times the 5 rupees per onion. I took the plus the 6 potatoes I wanted to buy times the 10 rupees per potato plus the 2 tomatoes times the 8 rupees per tomato. And what does that mean? That's the total cost of what I want to buy. Right there. If you do this right, those sort of things happen. Okay? Yes, sir?
Does orientation matter for the second?
It does. You're going to go row, column, row, column. If this is the first, and that's the first, that's the first.
5, 10, and 8 are distributed as a row.
Then we can't do it.
So
Because it has to be the same.
There has to be the same numbers here as the same numbers here. Has to be. Otherwise, it won't work.
what if they decided to do the chart costs on that and it said onions, tomatoes?
Then it wouldn't work. And that's not the way. Matrix math is directional. You have to do it in order. Because this is row and this is column. You can't switch orders and get the same answer. It doesn't work that way. As funky as that sounds. But then you'd be multiplying onions times tomatoes and things like that too, which would be a problem. You did something wrong. Okay? All right, as far as that may be, I'm going to give you some practice because you're not going to remember this without a practice. Actually, I won't remember without practice.